Hello everyone, we are solving question number 51 of GATE 2021 Chemical Engineering paper, and the subject is Instrumentation and Process Control. The question is, a process has a transfer function g of s is equal to y of s upon x of s is equal to 20 upon 90,000 s square plus 240 s plus 1. Initially, the process is at a steady state with x at time t equal to 0 is 0.4 and y at time t equal to 0 is 100. If a step change in x is given from 0.4 to 0.5, the maximum value of y that will be observed before it reaches the new steady state is a dash. So here we have been given a second order system, second order transfer function in the given question. So transfer function of second order system we have been given, and then we have been provided that the process is at steady state with x at t equal to 0 is 0.4 and y is at 100. So the steady state value of y is 100 and x is 0.4, and then we are introducing a step change of from 0.4 to 0.5. So we are changing this as 0.5. Then we have to find the maximum value of y. So for a second order system, if we have to see the response corresponding to this step change, we can draw the plot as like this. Let's just consider this as 0. So in general, this can be, so it will increase up to some point. No, not like this. So let's just consider this as 0 and this is our steady state. So it will start from 0, keep on increasing until a fixed point. So this will be the maximum value. From over here it will again decrease, reach a minimum value, then in such a manner it will keep on oscillating. At some time it will reach a steady state. So in this given question we have to find this maximum value, and this entire thing is y max. So we have to find this. So first of all we will compare this equation, that is g of s is equal to 20 upon 90,000 s square plus 240 s plus 1 with the general transfer function equation, that is kp upon tau square s square plus 2 zeta tau s plus 1 to find the parameters of the system, that is tau and zeta. Once once we have that, then we can calculate the, let's say we can calculate this value, and from the formula of the overshoot or decay ratio, then later on we can calculate this value also, and then we can just add both of this term to find the maximum value. So let's do that. So comparing both of this, we can see that tau square is 90,000. So from that we will get tau as 300. Then the second term is 240 is equal to 2 zeta tau. From over here we will get zeta as 240 upon 2 into 300. So damping factor is 0.4. So the value of zeta we found out as 0.4. Now Now we can write this overshoot as, let's call this as A and this as B. Then overshoot can be written as A upon B, and for that we have a formula of exponential of minus of pi zeta upon under root of 1 minus zeta square. So we have the value of zeta that we can put over here, and then if we have this A and B, we can just sum them to find this y maximum. So for that, let's just find this value of B. So that is basically this term that we can calculate by finding the final value of the system, basically the steady state of the system. So that we can calculate using the final value theorem. So from final value theorem, we can write the B, basically this entire magnitude B, as limit s tends to 0 s into y of s. Y of s we can write it as g of s into x of s. Now in the given question, we can see that we are providing the step change in x from 0.4 to 0.5. So basically the magnitude of the step change is 0.1. So that is, we can write xs as 0.1 upon s, and we have the value of g of s. So we will replace the value of xs gs in this equation to find the value of b. So it will become b is equal to limit s tends to 0 s into transfer function 20 upon 90,000 s square plus 240 s plus 1 into xs is 0.1 into s. This will get cancelled out, and we can put the value of s as 0 in this equation, and we will be getting 20 into 0.1 upon 90,000 into 0 plus 240 into 0 plus 1. So this will be b. This will be 2. So the value of b, we are getting it as 2. So basically we calculated this magnitude as 2. Now we need to find this term, that is a. This will calculate it b. So we know that the ratio of a upon b is known as overshoot, and its formula is exponential of minus of pi zeta upon under root of 1 minus of zeta square. We can replace the value of zeta calculated in the earlier slide as 0.4 in this equation, and it will become 0.4 square upon the root of 1 minus of 0.4 square. So this term should become a upon b is equal to exponential of minus of 3.14 into 0.16 upon the root of 0.84. You can again calculate this a upon b as exponential of minus of 1.371, and then this will become somewhere around 0.254. And from the earlier slide, from the final value theorem, we calculated the value of this b as 2, that we can replace over here. 0.254 into 2. So we will be getting the value of a as 0.508. So we have the value of a as 0.508. So now we need to find the maximum value of y. So in this plot, we are starting the system from over 0. So that is, we are considering the deviation variables. So that is basically y of t is equal to y of t minus of y of s. So this is ys, this is our steady state value of this given question. We have been given as 100. So this is 100, and this is the value at maximum value that we need to calculate. So the maximum value from the given plot was this a, yt will be a plus b. So this is the maximum value. So a we calculated it as 0.508 and b as 2. So this will become will become 2.508. We can put it over here. 2.508 is equal to minus of 100. So the maximum value of y will be 100 plus 2.508. This will become 102.508. So we will report the final answer as 102.5.